This is Twit.
Bandwidth for Know-How is brought to you by CacheFly.
This episode of Know-How is brought to you by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. And by CuriosityStream, a subscription streaming service that offers over 1,400 documentaries and nonfiction series from the world's best filmmakers. Get unlimited access starting at just $2.99 a month. And for our audience, the first 2 months are completely free if you sign up at curiositystream.com/twit and use the offer code TWIT. Today on Know-How,
distance networking.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Balloser.
I'm Brian Burnett.
And for the next 30 to 45 minutes, who knows, we're going to be showing you some of the things that we've been geeking out to so you can take them home and geek out on your own. Brian, how you doing?
I'm doing well. I'm still recovering, I think, a little bit from last week.
Yeah, last week was pretty intense. Las Vegas, NAB. Hot and juicy crawfish.
Oh, man. If anybody has not been to Hot and Juicy, do yourself a favor, go to Vegas. They're in other places.
Yeah, they're
Vegas.
they're in Vegas, they're in Los Angeles, they're in DC and Orlando, I think.
Right.
Yeah.
Like if you ever wanted a dining experience that somehow mimics the effect of Dexter, you know, the serial killer, that's the place to go because everything is covered in plastic. And then you put layers of plastic over your hands and you have the most delicious crab ever.
It kind of satisfies that inner child desire just to throw things.
Yes, it is
you're
messy.
supposed to. That's
Do
how
not
you
touch
get rid
your
of it.
eyes after that.
No. In fact, my father did rename that restaurant to Hot and Juicy Bowel Movement. So depends on how spicy you can handle.
As a traveling treat, I highly recommend it, but I would not make a habit out of it.
I wanted to do what we did the last time you were in Vegas, which is go there right before you get on a plane, because that makes that experience miserable for the rest of the passengers.
So much garlic
and spice.
So much garlic.
But no, we're not here to talk about crawfish. We're not here to talk about those delicious, delicious spicy sausage and snow. I'm sorry, no, we're back to the show.
Snow crab.
Snow crab. Instead, we're here to do a networking special. There was actually a question that was asked a few weeks ago. We wanted to throw it into one of our Q&A sessions. Unfortunately, surprisingly, I packed the show with too much stuff.
How does that happen? I don't know.
I know, it happens all the time. But we wanted to give it its own show because it actually brings up a lot of really good topics, a couple of networking issues that we can bring up and illuminate proper network design with.
Yeah, no, I always love those episodes because you're a network guy. You're an enterprise networking guy.
That's what I like to do. And, you know, I'm learning now that my task is to take what I've learned on the enterprise side and make it affordable, because I can't say that the solution for everything is a $5,000 switch. That just doesn't work.
Right. Not everybody has the hardware that you do lying around.
Precisely, which is why we're going to give you an easier way to do it. Hey, Brian, you want to go ahead and open us up with a little bit of feedback?
Yeah. All right. This one comes from Argyle the Gargoyle.
I like that.
I currently have my entire house networked, but I am running into issues with getting any type of stable connection to my garage. I have converted my garage into my man cave, complete with 60-inch TV, gaming PC, and various consoles. My current setup uses a Netgear Powerline 1200 adapter to get a connection to the garage, but it is very unstable connection. I would like to run buried cable out to the garage, but I have some concerns. It's roughly 200 feet from the house and to the garage. I also live in the Midwest and am concerned with a lightning strike hitting the cable. Any suggestions on how I can get this set up would be greatly appreciated. And all those concerns are completely valid.
They're so valid. Yeah. You would not believe exactly how valid they are. I mean, okay, so let's break it down. First of all, we know man cave. And if it's man cave, it means a lot of bandwidth intensive stuff. This isn't just browsing. This is someone who's probably going to be watching streaming video.
Streaming video, gaming. You want lag.
Lag time, lag will kill you. And so that kind of dictates a few of the technologies that we want to use and we don't want to use. So let's start with that. Let's start with high bandwidth, low latency. We know that's what he wants. And we know that right now he's using Netgear 1200 power line adapters, which I've used, I don't particularly like. Because like him, I found that since the conditions inside your electrical system are always changing based on what appliances are turning on and off, you can go from a super solid connection to it just doesn't work. And well, like for example, at the house in Henderson, I found out that every time the compressor on the refrigerator turned on, suddenly our available bandwidth would drop in half because it was such a noisy device. It just kind of blotted everything out on the electrical system.
In my house, it was a microwave. Every time the microwave would come on, the wireless would just drop.
Precisely. So you need to look for those sorts of things. Power line may be great if, let's say you're hooking up a printer and it's okay if the printer's lagged out by a couple of minutes.
What does a printer need?
Who cares?
Barely anything.
Right. But I mean, if we're talking about the main source of bandwidth for a man cave, no, we're not going to do it. Okay. So let's really quickly, let's take a look at what we've got. So we've got the house, and for in my mind, his house is a box.
Wow, what a nice house.
I know, that's most geeks live in boxes, right? So this is where his house is, and over here, because you know, man caves are circular.
That's the man. Are we looking at it from like top down? Is that it? The view?
Kind of.
Okay, continue.
No, this is the limits of my drawing abilities. So you just watch, sir. All right, so we've got all the bandwidth over here. I'm assuming that he's got a steady source of either cable
to his house,
or
from his
fiber.
ISP.
Precisely. And we've got a link that's 200 feet away. Now, 200 feet isn't so far that we couldn't consider wireless. Wireless is actually the cheapest way to do this. What you'd want to do is you'd want to throw two directional antennas against each other. So you'd have a bridge with, I would dedicate access points for this, because I think a mistake that a lot of people make when they create a wireless bridge is they use the access point for multiple devices, and you don't want that. If it's going to be the primary source of bandwidth for a particular area, you give it its own channel, you give it its own SSID, you give it its own encryption key.
So man cave, password.
Yeah, precisely.
Man cave.
Exactly, and you would put it like on channel. You would actually give it a 5 gigahertz channel or a set of channels if the bridge supports it. At 200 feet, it should be pretty solid, especially if you have two 5.8 gigahertz antennas that are pointed at each other.
Right at each other, yeah.
However, there was something that was mentioned in the question that is maybe not so good. If it is a man cave, he's doing gaming. I don't like gaming over wireless bridges. It's the same reason why we tell people who Skype into the TWiT TV network, get wired.
Yeah. Because
wireless can be unpredictable, and you don't want whatever, a sunspot to suddenly cause you to drop out in the middle of a match.
Right, and it sounds like it's all on his own property, so it might be not too difficult to lay a hard wire.
Precisely. If he had no other opportunity, no other thing that he could do, like for example, if he had his man cave 200 feet away and someone else's property was in between, you'd have to go wireless, because you can't drop a cable over someone else's property, right? Unless you wanted to spend for a laser, and most people aren't going to buy a laser to shoot 200 feet.
No, I don't think so.
Yeah, no. But that means we're going to be looking at some sort of physical cable. We're not doing a wireless link. We're not doing a power line link. He wants either Ethernet or fiber in the ground.
But fiber, then you'd have to get a fiber switch.
Well, let's talk about this, because we've got a couple of things that we can suggest to him. The first is direct burial Ethernet cable. This is probably going to be the cheapest solution. In fact, go ahead and go to that first link, Alex. The APC PNet Power ProtectNet Surge Protector. It's a 10-100 1000 device. Very, very inexpensive. You'd get two of these, one on either side. Now, you know, you would plug the Ethernet cable into it, and obviously it would hopefully ground out any surges that you might get from a lightning strike. I know there are people out there who are thinking this is kind of silly, but I actually have lost equipment to lightning strikes.
No, I mean, so the other show that I produce, Ham Nation, one of our hosts, their antenna got hit by lightning, and it blew out not only their transmitter and stuff, but it went into the computer because he had it linked up. And so he had to buy all new equipment.
I lost, back in the day of like the 3Com NBX phone system, the PBX system, I had a single cable that was going through the attic. and there was a lightning strike. It did not hit, but it hit close enough where enough energy was transmitted into that cable and it blew out the phone system.
Oh, wow.
So we had to get a bunch of these little power suppressors in order to protect all the lines that were going anywhere that might be unshielded.
So, I mean, if you're laying along outside Ethernet, this is probably a good idea to do. And it doesn't look like it's not going to cost a lot to do that.
It would cost $40. You would need one for each end.
Yeah.
However, you don't just want to take the regular Cat5 cable that you would buy in a box.
Because you're going to put this underground. So.
Yeah. In fact, Alex, go ahead and go to that second link. This is direct bury. So this cable, it's armored. It's designed to be put into the ground or into conduit that you put into the ground. You could run standard Cat5e, and probably in 2 or 3 years you'd have to run another length because it would degrade. And what I don't like about that is it's not as if one day it just won't work and you go, okay, time to replace the cable. Like the connection will get worse and worse and worse and you'll get more crosstalk until finally you go, I need to replace this thing.
Is that built in? Is that built-in obsolescence?
Yeah, well, I mean, it's not designed for that. I mean,
okay.
That kind of cable is designed for premise, which is inside. It's not designed to be put underground where it can be moist, where it gets exposed to microbes that might break down PVC, things like that.
Yeah. I guess, too, you would have to be worried about marking where you laid the cable so that you didn't dig it out again. That's
actually a very good point. You would want to like put little flags.
Yeah, or something.
Just so people know that there's a cable in the ground.
Right.
Now, for Ethernet, I'm not all that concerned because it's cheap.
That's true.
Now, this is 300 feet of Cat5e. That's the link that we showed of direct burial. So that will get from point A to point B, and that would give him a nice link that would allow him to use all his existing equipment.
And then he's hardwired. And
he's
hook
hardwired.
Up all his gaming machines, yeah.
There are a few things, though.
What?
The first is, so the max length of an Ethernet cable is 100 meters, which turns out to about 333 feet. So he's not at that. But as you get longer and longer and longer, you do increase the risk of crosstalk.
So what is crosstalk? I know we've talked about it before, but I need a refresher.
Right. So inside of an Ethernet cable, you've got a send pair and a receive pair, and each is twisted, right? So the idea is the send pair talks. It has data transmitting this way, and the receive pair has data transmitting that way, and it just goes back and forth, back and forth. That's how two devices, in this case switches on ports on switches, would be able to communicate with one another. As you get longer and longer, there's more of a chance that the tiny little signal that's going down that cable will actually get radiated and picked up by the other pair.
Okay.
Yeah, especially as you untwist the cables, it becomes more and more of a problem. Now, for most of us, 5 feet, 10 feet, 20 feet, even 100 feet, it's not a problem. No.
Right.
But once you get over about 150 feet, you do start to get at least a minimum amount of crosstalk. Up to about 300 feet, where you can still get signal, but you know, I very rarely have been able to get the full spec, 333 feet. Right around 300 feet, you get enough retransmits where you start to go, it's no longer
not worth it.
Stop. Yeah.
Okay, but 200 feet, he'll probably have a little bit extra, depending on how he...
Precisely. You will have a little bit of extra. However, as I mentioned, if you use non-direct bury cable, it will degrade. And if you're already close to the limit of that crosstalk, it will happen faster.
Now, it can happen when it's really long, but it can also happen when it's short, too, right?
It can happen when it's super short, right? You get a standing wave, and actually it acts more like a radio antenna than it is an Ethernet cable. But, okay, we're not going to get into that. So that is a possibility. I am not a big fan of that. I don't like direct bury Ethernet cables. A, because of the signal degradation, but B, because even though I've got power protectors on either end of this cable, there's still a chance that it will attract bad things from a lightning strike. Because remember, a lightning strike does not need to hit the cable.
It just has to be near it.
It has to be near the cable.
And then it'll push that through wherever it's connected to.
And what you're hoping is that it will blow out the power protection units on either end of that cable.
And not all the way to your access point.
Precisely. But, you know, I have lost gear even though it's been protected. So I'm not the biggest fan of that.
So we've got pros and cons for wireless and wired.
Yeah. Now, this is cheap, though. I mean, you're talking about, what, $140 and you're done. You got yourself the direct bury cable, you got yourself the 2 power protectors, and you can call it a day. But I'd like to maybe propose a few more expensive ways to
I
do
think
it?
so. This is where fiber will come in.
This
then.
is where fiber comes in. I like
Okay.
fiber. Okay, so let's talk about replacing the switches with fiber-capable modules.
Okay.
There are a couple of products that you could buy. Alex, go to the first one. This is the TrendNet. It's a 4-port gigabit switch. Well, what's important is it has an SFP slot. Now, what is an SFP? An SFP is this. If you go to the side view here, Alex, these are little fiber modules.
Oh.
So I've, just some of the
These
ones.
look very familiar because our old Mac Pros used to be hooked up to a fiber network here.
Right, yeah, these are except here we were using it for like direct connect. It was more of a storage area network. But it's the same idea. So these they take electrical signals on one side and they convert it into light pulses. Those light pulses will travel down fiber optic cables, and then boom,
And you don't have to worry about crosstalk at...
Not at all, because unlike copper, you are not creating an antenna. No matter how much data you push down these, you're never going to change the material so that it starts transmitting.
Right.
It will always just be light. Okay. So this does solve the crosstalk problem. It also solves the distance problem. So with multi-mode cable, which is this orange stuff, you can go, I think the maximum is, 1 point something kilometers? You can get a distance. Oh, no, sorry, a multimode up to 550 meters,
Whoa.
which is about 1,800 feet. So that's
plenty.
yeah. And then with the single mode, which is the yellow fiber here, you can get up to 15 kilometers.
Wow. Okay.
So yeah.
But this doesn't look like something you'd want to bury in your backyard.
No. So again, this is not direct bury. If I was going to use this, I would want to have it in a conduit. And even then, it's not really designed to be buried into the ground. Go to that second link first. Let's show them the SFP. So you need to get the switch, then you need to get an SFP. There are different SFPs that you can choose depending on what you want them to do and how fast you want them to be able to pump over data. What I would suggest is get a cheap one, because you're just looking for a gig connection. You want it to be multi-mode. Multi-mode's going to be less expensive, and that will do it. I mean, you can get these on eBay for under $10.
Okay.
And you need two, one for each side. You would also need a cable. Now, go to this third one. So this is a 100 meter. This is more than long enough. You actually have a nice coil on either end. This is not direct bury, but this is a multi-mode cable that will get me from SFP to SFP. So an SFP on one switch to the SFP on, in the switch in the barn, right? You will have to put this in some sort of conduit. Now, this actually could be about the same price as doing the direct bury Ethernet route, but it would be faster.
Okay.
I kind of like that. Fast is good.
So what's the cost difference if we were to do one versus the other?
Well, the cost difference would be this. Alex, go to that next link. You do want direct bury fiber. Now this is great because this will not degrade. You will not have to replace this. You put this in the ground, directly into the ground. It's 100 meter. You have a service loop on either side in case you need to move something, and it actually gives you multiple pairs. So you can hook up multiple ports and get yourself a bit of a bonded performance. Or for example, what I would typically do is I would have two ports off of each switch, so that if I lose a port or lose a pair, I don't lose my connectivity.
Okay.
But yeah, that's $400. So.
But this seems like probably the most reliable solution, and as far as transfer speed, best solution. And then also you don't have to worry about it if
Lightning
there's an
strikes.
electrical
Yeah,
storm.
there is no lightning strike that's going to travel down fiber.
So say someone does dig this up and cuts the
way
line.
expensive.
You can't just splice it back. So you'll have to buy a whole nother...
I mean, you can, but you have to have a lot of skill. And like Brian Chi can do it.
Right.
I can struggle to do it. He's much better. It's hard.
I mean, don't you lick the ends of them and then you just tape it back together?
All right. Let's go back to our beautiful picture here. So we've got a couple of ways to do it. We can do wireless, and we're not doing that. We can do Ethernet, and we can do...
So fiber is squiggly.
Fiber is squiggly.
Yeah.
Now, so this is going to be the least expensive. Wireless is going to run you maybe $100. The Ethernet direct bury with protection modules is going to run you about $140 to $150. The fiber, at minimum, is going to run you, if you don't want to use DirectBerry, like $180.
Okay.
But it is better. It is far, far better.
How much is your man cave worth to you?
Exactly. Now, there is one other opportunity that can kind of reduce the amount of initial outlay, because the solutions that I've been giving so far have been based on replacing the switches. He might actually like the switches that he's using right now. And if that's the case, then you can use what's called a media converter. Alex, if you go to the first one, this is a TP-Link. It's a relatively inexpensive box. You're talking about $46. If you wait on eBay, you can get these media converters for like 20 bucks. All it is it has fiber that goes in on one side and Ethernet that comes out on the other.
Right.
Which means you can use the switches that you already have. You don't have to throw them away, or you don't have to add another switch. I kind of like that solution because it makes it modular.
That's probably the one I would go with.
Yeah, yeah. And so you'd be looking at an endpoint for that. So that's less than $100. Actually, so let's assume that you can get the deal. You're talking about $50 for the endpoints. You're talking about maybe another $100 for the regular fiber, or $400 for the DirectBerry fiber. So this could either be an expensive version or a super, super cheap. This could actually be cheaper than the Ethernet version.
Well, you know what? I think our know-it-all should send us a picture, a map of his yard, and then we'll figure out like if it's worth trying to, go around. If he has a swimming pool or something, or a garden that he has to tear up to get through. But or I'd be curious to know what solution he goes with.
Yeah, and one of the things that we need to remember anytime we're talking about networking is there is a fine line between making it as good as we need it to be and as good as we can afford it to be.
Right.
And most of the time, those two do not match up. What I would say, my advice would be, spend as much as you can getting it right the first time, because especially with these long distance runs, it's incredibly, incredibly annoying if it goes down when you need it. And I can almost guarantee you it's going to go down in the middle of the rainy season, when it will not be easy to access whatever conduit you buried.
Right when you're trying to get that final kill in Halo or something.
Right, exactly. and then you'll resort to wireless. The other thing I would suggest is have a backup. So if you're going to go ahead and do fiber, why not also set up the wireless APs? It's not that much more expensive, and there are even routers out there that will auto switch. They'll go from one connection to the other. You can tell it use fiber primarily, but if the fiber goes out, go ahead and switch to the wireless.
Redundancy.
Redundancy.
We're always trying to think of ways that we can fail-safe our projects.
Precisely. I think what we're really saying is there are definitely options that you can take. And you can spend as much or as little as you want, and get as much or as few features as you desire. What about that?
No, I think that was a good solution. All three of them.
Well, you think so? Because I'm about to blow your mind.
We'll see about that.
Okay. I'll be blowing some minds after the break. First, we do want to take a moment to thank the sponsor of this episode of Know How. Hey, Brian, I've talked about DigitalOcean a lot.
Yes.
Yeah, we've had them on not just the show. I've had them on like Coding 101. I've had them on This Week in Enterprise.
I'm glad to have them on as a sponsor.
Yeah. And what I like about them is that they really they try to change the way that we host ourselves on the internet. It used to be difficult. I remember I'm an old guy, and I remember what it was like to try to get something on the internet. You had to find a space. You had to find the hardware. You had to contract with someone for connectivity, and you also had to make sure that you had someone who was there for maintenance. Now, you did all this because you wanted to be able to control the look and the feel of your server. You didn't just want to rent a server from someone. You wanted to own it. You wanted to make sure that you could control every intimate aspect of your infrastructure. Well, that was expensive, it was time-consuming, and honestly, it was a pain in the enterprise arse. Well, luckily, we've got DigitalOcean. They take that whole process and they shorten it. They make it easy for you to deploy your server, for you to deploy your portfolio, for you to put the next killer app on the internet with just a click of a button. You see, they use these things called droplets. They're containers that will take your service, your app, whatever it might be, and run it on their infrastructure. Now, the nice thing about it is that it's used by over 600,000 developers, including Twit's Randall Schwartz, by Aaron Newcomb and myself. And we all understand that it's the easiest way for us to deploy and configure anything we need. You use their streamlined control panel or simple API. You can auto-deploy. You can even do one-click installs of things like Drupal, Docker, and Node.js. what I really like is the customizability. I can choose my OS, Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD, and then I can select from a pre-configured installation, or I can set it up exactly the way that I want, just like I used to when I owned the server, when I owned the space, except this is all in the cloud. DigitalOcean is highly scalable to meet your demands. You can start small and then expand as your service gets bigger and bigger and more popular. You could also use advanced features like floating IPs for high availability, for private networking, and for automatic deployments via their API. They've got an extremely active community, which I don't just want, I need, because it tells me that the service is good enough, that the customers are loyal, that they come back again and again, not just to keep using DigitalOcean, but to help people who are new to the service. Brian and I have been talking about putting a Minecraft server inside of a container, inside of a droplet, and the first time I used it, it was sort of, well, an aha moment. It was, why are we doing it any other way? Why aren't we using DigitalOcean? And in fact, that's the question I ask you. Why aren't you using DigitalOcean? It's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. DigitalOcean has incredibly affordable and straightforward pricing, with servers starting at just $5 a month. And there's also hourly pricing available starting at less than a penny per hour. But we're going to make it so that you can get started today and deploy an SSD cloud server for free. Just visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com, DigitalOcean.com, and once you sign up, enter the code KNOWHOW in the billing section to get your free $10 credit. And we thank DigitalOcean for their support of KnowHow. So Brian, when we come back, I'm going to show you some interesting aspects of setting up a network like this. And specifically, I'm going to give you some enterprise knowledge. But before we do that, you mentioned that the best way to clean fiber is on your shirt, right?
Yeah, right?
Just,
that's how...
Give me a little spit, a little polish.
That's how I used to do it.
Yeah, exactly.
No, God. No one would
ever
ever let me near the fiber when we were using it down in the basement.
And actually, this is important because a lot of people think that running fiber is just like running Ethernet, where you just like clean it off, maybe blow on it a little bit, and then plug it in.
Yeah.
That can actually destroy a fiber network. And if our friends out there are going to try to run a fiber network, they should at least know how the pros clean their fiber.
Hi, I'm Tyler Vanderplug from JDSU, and today we're here at Interop and we're building this very high bandwidth network. And one of the biggest things that we're paying attention to today is making sure that all of our fiber connections are in pristine condition and clean enough to transfer the data from each server to server or to each cabinet. And so I wanted to walk through one of the products that we're using in doing this and how it makes it a lot easier. Around my neck here, I have what we call our Essential Fiber Toolkit from JDSU. It features our popular HP3 series integrated system, which combines 3 tools in one, actually. It includes a microscope for inspecting the patch cords, which I'll do in a moment. Also a second microscope for inspecting the connector behind the bulkhead. And it also includes an integrated power meter. And there's other tools that are included with it, such as a visual fault locator, cleaning tools, and things of that nature. So I'd like to walk through just the process of how this is used right here on an actual system that's being used on the Interop floor. We'll start off by checking our test leads on one of our patch cords. So I'll turn on my device, and I have my integrated patch cord microscope here. So I'll check that. I'll check the first connector, and it's pretty dirty. So right next to my microscope, I have an integrated cleaner. Give that a click and re-inspect that. Now I've validated that that end is clean, so I can actually move it over here to my power meter port. Whether I'm using my power meter or not, I can put it there because it's a nice safe place to park that connector when you're not using it. Check my other end. This one as well is pretty dirty, so I'll give that a clean. Now that's a lot better. So now both of these ends are ready to go. But before I connect those, I want to make sure that the connector behind the bulkhead port is also clean. I'm now going to transition over to my probe microscope, which allows me to inspect behind the bulkhead port. I press a button on my display here. That activates the probe. I'll go ahead and inspect that in here. Get that into focus. And that one is pretty dirty. I'm gonna check both at the same time, and both of them are pretty dirty. So my cleaning tool, the same device that I used to clean the patch cord ends, I can also use to clean behind the bulkhead. I just remove the cap, give that a few clicks in there, and now I'm gonna re-inspect. Now I've confirmed that both my patch cord side and the connectors behind the bulkhead are clean, so I can move ahead and actually connect those. Now, I need to plug in the other side. Now on this particular application, that side used an SC connector. On the other side is using an LC connector. So in order to inspect this one and clean it, I just need to change the adapters. This one here was meant for a universal 2.5 interface. I'm going to put on a different adapter for a 1.25 interface, which is what you'll usually see on an LC ferrule. Now I need to do the same with my bulkhead. I had an SC tip on there for inspecting the SC port. I'm going to change that out to an LC tip instead. Put that on there and thread that. Now I'm all ready to go to inspect the LC patch cords and the ports behind there. So I go ahead and get this into focus. Actually, both of these are in great condition, which is another good reason why you always want to inspect before you connect, because if you don't need to clean, you don't need to waste the time doing that if you've already validated that these ends are clean. So now these two ends are clean. I'm going to toggle over to activate my probe microscope. And hey, guess what? All of these ends are actually already clean. So we've validated now that these ends are clean, and we didn't even have to check them. Let's hear it for interop. We got some clean connectors here. So now I've validated that those ends are clean, so I can plug that in. And now I've connected both ends of my SC and my LC over here and made sure that every end face was perfectly clean. And remember, inspect before you connect.
That's actually important.
You can apply that to a lot of things in life.
This is true. Inspect before you connect. But what a lot of people don't realize is that if they push a dirty fiber into a port, they're actually pushing dirt into the SFP.
And then it's a lot harder to clean that than
it's way harder. And so we've got specialized tools. You don't necessarily need that microscope, but what I do tell people is that you always want to clean the fiber and the port before you put it in. In fact, this fiber, this is all bad fiber. This is junk fiber, because normally I would have them capped. I would have a cap on each end, because when they're like this, and like I just put my oil. I put the oil from my hand on the tip, and now it's collecting dirt, and it looks clean, but you got to remember, I mean, we're talking about a really small optical core, so anything can get in the way of that light.
Interesting. So does this apply to, you know, the audio cables that you have that do the red light? Like, does it matter?
Like the toss link? No,
no, those aren't as sensitive.
They're not pushing nearly as much data as this, so I mean, they can survive a little bit of an error.
Well, so if you're doing this at home, as you know, I don't have that equipment. How do you know if it's clean, or if you can you clean it yourself without that tool that he had?
Well,
because that was how much did you say that tool was?
You would need a microfiber cloth. You dropped an SFP on the floor there.
Oh, they're durable. Oh, there it is.
There we go.
You need a microfiber cloth?
You need a microfiber cloth. What I have is I actually have, it's an automated machine. So it has a microfiber cloth on a roll, and it just like cleans it. So you advance it a little bit, and then you rub the fiber on it, and that's it. That's good. And then I also have a tool that you can put into, it's basically a revolving tiny little microfiber.
Yeah.
You put it into the port, and every time you punch it, it actually like moves the microfiber, and it kind of brushes the dust away.
So in the end, though, it probably just try not to get your fiber dirty to begin with.
Just don't get it dirty.
Yeah. So
anytime you take it off, cap it. So those caps that you have at the beginning, that's not just like the plastic that comes on something you buy. Keep that. I always have like a little baggie that I attach to the fiber, so that when I detach the fiber, the ends will be right there. I just recap them.
Okay.
In fact, what I'll normally do if I'm disassembling a network, I will clean it before I recap it, so that I know that when I take it off, it should be clean. But even then, every time I connect fiber equipment, I clean. I clean. It's, you got to be kind of OCD about
with
it.
it. Yeah. Well, I guess the benefit though is that once you have it all hooked up, there's no reason that you would have to be unplugging these all the time, especially if it's in the use case of our project.
Right, precisely. Well, when we come back, I want to show you the difference between single mode and multi-mode fiber. I want to explain why you might use one over the other. But before we do that, I do want to talk a little bit about a relatively new sponsor to the show that I'm actually very excited about. I spent the weekend watching CuriosityStream. Now, CuriosityStream, think of it as it's a video service for those people who spend most of their time watching documentaries and nonfiction science/engineering programming. It's a recognition that there are those of us out there who, when we're watching other services, we're hunting for these rare pieces of video content. We're looking for the documentaries that no one else cares about because we're geeks, we're proud, and now we've got a place of our own. Now, CuriosityStream puts over 1,400 titles and 600 hours of content at your fingertips. It's available in 196 countries worldwide, available on platforms from the web app, Roku, Android, iOS, and Chromecast, Amazon Fire, Amazon Kindle, and Apple TV. They offer a wide variety of science and technology content, plus nature, history, and many more topics. You know, the stuff that you love. Over 50 hours of 4K content, which they've just launched, which makes them one of the largest 4K libraries on the internet. In addition to documentaries, they also have interviews and lectures. Again, these are the things that normal people would look at and go, why would I want to listen to a lecture? Whereas geeks, the people who watch Know How, are saying, yes, please, I'd like to watch some lectures. Their library includes Stephen Hawking's Universe, a series where Stephen Hawking traces the history of astronomical theories and technology. The Next World, featuring Michio Kaku, I love his name, talking about the future of technology, virtual reality, artificial intelligence, and other big technology questions. The Human Face of Big Data, which is currently exclusive on CuriosityStream. And even The Road to the Singularity, which is what I watched. Jason Silva and other experts explore the inevitable arrival of superhuman intelligence in a CuriosityStream original documentary. It's got monthly and annual plans available, and plans start at just $2.99 a month. That's less than a cup of coffee or the cost of one title on a less competing platform. Folks, if you love science, if you love engineering, if your mind needs to be fed, you need yourself some CuriosityStream. Check out curiositystream.com/twit. That's curiositystream.com/twit and use the promo code TWIT during sign-up to get unlimited access to the world's top documentaries and nonfiction series, completely free for the first 60 days. That's 2 entire months free of one of the largest 4K libraries around. Just go to curiositystream.com/twit and use the offer code TWIT at sign-up. And we thank CuriosityStream for their support of Know How. All right, Brian, whenever we talk about fiber, I always get people with that glassy look, the glazed look, because they're
yeah. Like the face is going to start melting off?
The face melting, whenever I try to describe the difference between single mode and multi-mode.
Let's do it. Give me the face melt.
It's important. Okay, so we talked a little bit about this. When you're talking about single mode, so that's all this orange stuff.
Okay.
This
always color coded like that?
It's pretty typical. Multi-mode will typically be orange. Single mode will typically be yellow.
Okay.
Not always, but most of the time. In this use case.
Right.
This will go 550 meters, which sounds like a long way. That's what, 1,800 feet.
That's enough for our project.
It's enough for our project, but there's a different kind of fiber, and that's this. This is called single mode.
Right.
Now, single mode actually goes far longer. You're talking about 550 meters, so half a kilometer for the multi-mode. This will do 15 standing on its head.
Wow.
Yeah, and people look at it and they go, but okay, so is it the color that makes it go longer? What's the difference?
It looks a little thicker.
It is a little thicker, but that's the multi-mode is thicker. And so people are like, well, shouldn't that be able to carry more? Yes. And no.
All right, Padre. Give me the details. Why?
Right. Here are the deets. When we're talking about multi-mode, we're talking about the typical constructions would be, let's see, what is that? 50 125 or 62.5 125. Those are measured in microns. And what those numbers mean is how big is the core versus how big is the cladding.
What is a cladding?
No, we'll see. Inside here, if you, okay. So here,
Let's get our microscopes out.
I know exactly. The core that's not actually the core. Those white things,
right?
That's the cladding that contains the core. The core it's only 50 to 62.5 microns. It's incredibly small. The rest of this is just armor. It's a way to keep the fiber from getting pinched or damaged or whatever.
Right. It's like any wire that has the rubber coating around it. Right.
Right. Exactly. But even though it looks really small, the thing is 50 or 62.5 microns is actually really big when you're talking about light.
When you're talking, like photons of light.
Exactly.
Okay.
So what will happen inside of a multi-mode fiber is the light will actually bounce around the inside of the core.
Okay.
Because every time it hits like the edge of the core and gets to the cladding, it will want to bounce in the other direction, bounce around. Now that means I can actually, as an IT engineer, I can actually use that phenomenon to push more data through. I can what they've mastered with multimode is you use different lasers on the same fiber that are running at different angles, and they're running at different not polarities, but I can't remember, spins for light. And you can actually have that all go through the same fiber at the same time. I can push easily 40 to 100 gigabits per second through one of these things.
Okay. And then, so I'm just guessing it's the yellow one. This is just a smaller space for light to pass through?
It's a smaller space of light. You can only do one mode, only one beam at a time. Now, this means I can carry less data with a single mode cable than I can with a multi-mode cable, but it also means with multi-mode, with that light bouncing around, you eventually get to a point where it's all become gibberish.
I see. Okay, the way I'm trying to comprehend it in my mind is if there's like a 4-lane highway and there's all the traffic is crisscrossing and trying to get all to the same point. Like at a certain distance, all the cars just start running into each other. Is that kind of what's happening?
It's kind of what's happening. In fact, I just realized we shouldn't have turned this thing over.
Because we should draw this out.
We should draw this out. We should
really
show you.
Push Padre's art to the limit.
I know what art. I don't.
The art of art.
I don't do art. I do PowerPoint, folks. It's different. All right, so let's get rid of my really expertly drawn drawing of his
house
man
and
cave,
which is a circle.
Yes, let's get rid of that. And instead, let's look at what. Let's start with a multi-mode fiber. So a multi-mode fiber might look like this. So here's the outside cable. That just protects it. And then you've got your cladding. And the cladding is a layer inside that kind of contains the core. And then you've got, so this is all.
So that's the plastic that's protecting it.
Right. And then the core is like that. It's actually really small.
Wait, so there's something in between.
I know this is
another insulating layer?
Yeah, that's the cladding. So you've got the cladding. So the only thing that's active is this core inside. And in a multi-mode fiber, what's happening is the light is bouncing around like this.
Right.
It just keeps bouncing back and forth, and I can actually use that to take multiple paths of light, which will be recombined at the other side, which I can use to push more data, right?
Right.
Single mode, so this is 50 to 62.5 microns diameter, this core. Single mode is about 9 microns, so it's much smaller. So it looks kind of the same. You've got your outer core, you've got your cladding, but then the core itself is basically just that. It's one single line. There is no ability for signals to bounce around. You only have one going down at any given time. So you're not going to get that crosstalk. You're not going to get that mush. You're not, well, that's, by the way, this is a horrible drawing. You're not going to get any of the signal degradation effects that you get so quickly in multimode.
Okay. So, and can you send and receive data through at the same time on both of those?
No.
Or?
So that's why, if you look at this, every fiber pair is a pair. One is transmit, one is receive. You can't.
Okay.
Yeah.
That makes sense.
I mean, you could do it, but then it would be half duplex. Either it would be sending or receiving, not both. This way, I can send and receive at the same time.
Okay.
Okay. Now, people get kind of confused by this explanation, so I've got a really easy way to demonstrate it. And actually, I've showed this off on the show before, but it's been a while, so I thought we should do it again.
Sure.
This is just a laser. It's a network, it's an IT laser for enterprise, which means it costs a ridiculous amount of money, but I could just do this with a laser pen. I'm going to hook this up to the multi-mode, like so. What I'm doing is I'm shooting light into here. If you go ahead and drop the lights a little bit, Alex, and then go to the overhead, or go to the side view. There we go. So I've got that, right?
Yeah.
So that's the laser going through the fiber onto the paper.
That's cool.
Okay. Now, actually go back to that shot, Alex. Now look what happens. What I'm going to do is I'm going to like move the fiber. I'm going to crumple the fiber a little bit. See how that changes?
Oh,
See,
yeah.
What's happening is the shape of the cladding and the shape is actually changing, and it changes how the light looks.
Well, that's probably got to be bad for sending information across.
But I mean,
right?
it's used to it. I mean, this
it can.
Yeah. And then this, but it shows you that the light is bouncing back and forth inside of the cladding.
That's cool.
Okay? So let me show you what single mode looks like. We're going to do the exact same setup, same laser. But here we go. Now I'm going to go ahead and mess with this.
Yeah, like nothing basically. It looks like it's moving like a fraction, but definitely doesn't look
you
like.
get a little bit off the edges, but it's not changing like the pattern. You get a coherent light.
Yeah.
See, that's what single mode does. So single mode only has one light wave going through at any given time, which is why it stays together for so much longer. This is why this can go 15 kilometers versus 500 meters for the other one.
Okay, that makes sense.
Yeah, and that's actually something that you can play with. Anyone who wants to do a science project, if you want to impress people, go buy yourself a $40 laser diode, make yourself, 3D print yourself an interface between this and a fiber optics cable. You can actually use this as a security sensor. This is what we did. We ran multi-mode fiber underneath a carpet.
Yeah.
And we had it connected to a camera, and the camera just looked for differences. If you step anywhere on that carpet and it touches a multi-mode, it changes how the light looks.
And that triggers it.
It triggers.
That's
It was
awesome.
actually
Yeah,
kind
that's
of fun.
smart.
It was
Yeah.
pretty cool. They also use this phenomenon when they're troubleshooting networks, because I can use what's called an OTDR, which will send a pulse of light down a fiber. And if there's a break, because of the way physics works, if light is going through a changed medium, like a crack in the fiber, part of that energy actually bounces back.
Oh, so you get like talk back or something.
Yeah, so you send the pulse, and then when it comes back, you divide it by 2, and then you multiply that by the speed of light, and you know how far away the break is.
That makes sense. Wow. Okay, that's really cool.
Yay! So
I learned something
fun
today.
with lasers, Brian.
Wow. Okay.
I know. Now, folks, this is fun because I like playing with fiber, but you know, what we're really trying to do is to demystify this. There's a lot of people out there who they think they can work with Ethernet and they can't work with fiber because fiber that's pro level. Not really. Get yourself some fiber gear. Learn how to network it. Learn how to use it, because I find it to be one of the most useful things that you can do if you're a networking guy.
I would love to see how it's manufactured. Like, how do you make something that small and then wrap the coil around it and everything else?
They're actually elves. Really small elves.
That's what you say for everything.
Tiny little
How do
hands.
those quadcopters fly, Padre? It was elves.
It was
Don't
magic.
worry about it.
You know what keeps them in the air? Love. I learned that
I
from
knew
Firefly.
it. Okay. It's true.
Folks, we know that this has been a lot. We're going to make sure you get all the show notes inside of our show notes page, which, Brian, where are they going to find that?
twit.tv/KH. And not only do our show notes live there, but all our past episodes. So if you want to follow along with projects or catch up on some of the things that you might have missed, be sure to subscribe and download the version of your choice.
Yeah, absolutely. And don't forget that you can also join us on our Google Plus group. We have a link shortener. It doesn't always work. So just go to Google Plus, look for Know-How. We've got over 10,000 members. If you've got a project you want to show off, if you have a question you want to ask, or if you're an experienced DIYer or maker, you want to answer questions of people who want to tap your knowledge, again, go to Google Plus and look for Know-How. It's a great place for you to get on the show. In fact, we pull at least half of our content directly from you. If you want us to cover something, that's where you go.
Yeah. But if you want to get in touch with us and see kind of a behind-the-scenes thing of what we're doing when we're not working on Know-How, you can go to Twitter, and I am at @cranky_hippo.
And I am at PadreSJ. And of course, you have to remember our director, what is
Alex Grindle.
Grindle. Alex Grindle, who really likes drinking.
How come he has a drink?
It's orange drink.
Wait a minute. There's a lot of
I know,
laughing
right?
going on.
I don't know what's going on, but there's too many happy people in the brick house right
Excuse
now.
me, Padre.
Yeah?
It's pronounced Alex Gumpel.
Oh, let's see. No, I would have known that. I would have known that, but no, I haven't heard that before. Before we go, as we are wont to do, we love to show off projects that our know-it-alls have come up with. We've got something here. Hey, Brian, you want to read this off?
Sure. This one comes from Chris, and he was saying that since I hold Robert and Brian personally responsible for getting me hooked on multi-rotors, I thought I'd post my latest flying contraption here. The FPV 150 got me wondering if it would be possible to build a mini quad under the FAA's 255-gram limit that would include everything: FPV, OSD, lights, an APM flight controller, and GPS to do autonomous flight modes. I missed the weight limit by just 27 grams. Not significant, but not insurmountable. To trim, he could trim with modifications here and there. He designed and milled the parts on a small desktop CNC milling machine from various materials suited for each function. Wow.
I really like this. He built himself a responsive quad. Alex, if you go to that website and actually show them the pictures of the build, it's actually quite good.
If he has his own little CNC milling machine, he's got to know what he's doing.
We don't even have our own CNC. Actually, I have one, but I don't really have access to it. So what he did was he's got carbon fiber rods that are acting as the arms. He's got that 3D printed sort of bathtub where everything goes in.
Yeah.
Holds the motors. I love the fact that he put LEDs in the mounts, which helps with orientation. Because remember, we're talking a small little craft.
Those are slick.
Very
I like
slick.
those.
He did a great job with this. This is a build I would be proud of.
I'm kind of ashamed of our build now. Even though we have our little like Star Trek engines on it.
My friend, the gauntlet has been thrown. I mean, look at that. I mean, this
I kind of want
is
to build this
so
one.
neat and clean. I really like his design.
I think it even has landing gear on it.
Wow. Well, that's why it's 27 grams over.
Yeah. We're still under.
We're still under by about like 17 grams.
Yeah, we could put landing gear, and then the cute little antennas poking out like a little bug.
Now remember, this one does GPS, so it will do position hold. So if you wanted a 150 class quadcopter that you could like release the controls, and it would hold its position while you try to reorient yourself, this is a great solution.
I want to build that quadcopter.
Yeah, no, he did an incredible job with this. Kudos to you, Chris O'Reilly, and yes, we do take full blame for your quadcopter obsession.
Absolutely.
Yeah.
Enjoy it.
Until next time, I'm Father Robert Ballas here.
I'm Brian Burnett.
And now that you know how,
go do it.